the ratio of root mean square speed, most probable speed, and average speed, where symbol have their usual meaning, will be what? We must be knowing the formula for all of them. VRMS given by under root 3 RT upon M, where R is gas constant, T absolute temperature, and M is molar mass. On the other hand, VMP we can write under root 2 RT upon capital M, and V average is given by under root 8 RT divided by pi M, and we have to take the ratios of them. So ratio will be VRMS is to VMP is to V average given by RT by M, RT by M, RT by M will be cancelled out. So root 3 is to root 2 is to under root 8 upon pi. So after looking at the options, we can say that option number 4 is absolutely correct. So we'll go with option number 4. Now move on to the next, that is 12 number. Here is question number 12, everyone. If angle of dip shown by dip circle at 30 degree with magnetic meridian is 60 degree, then the angle of dip shown by dip circle at 45 degree with magnetic meridian will be what? Now here this is the case when a plane is making some angle with magnetic meridian, and we can write the apparent dip delta, or you can write the apparent dip tan delta dash is written as BV upon BH cos of theta, where theta is the angle dip circle makes with magnetic meridian. Now in case 1, delta dash is given 60 degree. On the other hand, theta 1 is 30 degree. Putting the values, tan 60 equals BV upon BH cos 30 degree. Equation number 1. Next, if the theta is changed, then magnetic meridian, that is 45 degree given, the theta is changed from 30 to 45, so apparent dip will also be changed. So theta 2 is given 45 degree. Then the next apparent is supposed double delta dash or delta double dash. So tan delta double dash given by BV upon BH cos of 45 degree. Equation number 2. Now taking the ratios. If we take the ratio, we will find tan delta dash upon tan double delta dash, that is tan 60 upon tan delta double dash equals BV upon BH will be cancelled out, and here you will get cos 45 degree upon cos 30 degree. Therefore tan delta double dash will be cos 30 upon cos 45 multiplied by tan 60. Now putting the values of trigonometrical ratio, we will get tan delta double dash as root 3 into root 3 divided by root 2, whereas double delta dash will given by tan inverse 3 upon root 2. So this is the final answer we have got, and if you look at the option, we can say that option number 4 is absolutely correct. So here is question number 13, everyone. A wire frame of given shape carrying current of 10 ampere is placed in uniform magnetic field 100 Tesla directed into the plane of paper as shown in figure. The net force acting on the frame. Now we know very well the net force acting on current carrying wire kept in magnetic field is given by F net, or F simply is I L effective cross B. And here in this case L effective will be from this point to this point. So let's write L effective vector, that is 10 centimeter or 10 by 100 meter. Direction is I cap. Magnetic field vector, vector B, magnitude 100 Tesla. Direction is inward the plane of paper, that is minus K cap. Now therefore the net force will be IL cross B, that is 10 into L, 1 by 10 I cap cross B, that is 100 minus K cap. So 10 cancel out, 100 I cross minus K cap Newton. We must be knowing K cap cross I cap equals J cap. Therefore I cross K is minus J. Therefore minus I cross K would be plus J. So here we have to replace just plus J cap. So therefore 100 J cap Newton will be the net magnetic force acting, and we can say that option number 1 is absolutely correct. We will go on with option number 1. Now move on to the next, that is 14 number. So here is question number 14, everyone. A closed current loop of any arbitrary shape placed in uniform magnetic field, then net force and net torque, the options are talking about. So first of all, we must be knowing that if any current carrying coil is kept in a uniform magnetic field, then forces are always equal and opposite, but their line of action may be different. Alright, so therefore we can write, when current carrying loop kept in uniform magnetic field, forces acts always equal and opposite. Therefore the net force will always be 0. But these opposite forces may have different line of actions. So if their line of action is same, then torque will be 0. But if they don't have the same line of action, then the torque will not be 0. So tau may or may not be 0. Now let us have the options. Net force on the loop is always 0. True. Net torque may or may not be 0. True. So we will go with option number 1 only, which is absolutely correct. Now move on to the next, that is 15 number. So here is question number 15, everyone. A thin rod carrying current I2 is placed near a long straight wire carrying current I1 in the plane of rod as shown in figure. How would be the motion of rod? Now we know very well the wire carrying current I1 produces a non-uniform magnetic field around it. So therefore forces acting on wire number 2 will be different at different elements. The force that will act here will be different, and the force that will act here at that element will be different. Alright, so therefore force at near end will be maximum because magnetic field due to wire 1 at that point is maximum, and force at farther end will be minimum. So it is very much clear from this fact that the motion may be, or motion will be, translatory as well as rotatory. So let's write, since magnetic field due to wire 1 is non-uniform around it, and therefore force at nearer end of wire 2 is maximum, and force at farther end of wire 2 is minimum, and hence the motion will be translatory plus rotatory. Therefore we will go with option number 3 only, which is absolutely correct. Now move on to the next, that is 16 number.